In the examples in this video, we're going to go through and write the domain and range that are associated with each one of these graphs that are given. Keep in mind from our prior discussion, domain is going to represent what our valid x values can be, and range are associated with what our valid y values can be. Smallest value is written on the left. Largest value is written on the right for each of these, as you can see. And when we write it mathematically that way, we can put less than symbols in there. And if we have open circles, there'll be less than symbols. If they're closed circles, there'll be less than or equal to symbols. On some of these, I will admit, it's a little difficult to tell if they're open or closed circles. So I'm just going to go with my best guess here as I'm looking at it. But it'll be obvious when you're doing it in the homework or on an assessment. It'll be obvious if it's an open or a closed circle. The other thing I'll mention is I'm only going to do a few examples off of here, and that'll leave remaining examples that your teacher can do with you in class if you have more questions. So on example number 1, our x values look like they go from a -7 to a +7. So -7 on the left, +7 on the right. X can be anywhere in between. And to me, those look like open circles. So I'm going to leave them at less than symbols and not less than or equal to. So my x values can be anywhere between -7 and +7. Now for my range, my y value remains constant. And my y value is literally equal to 3 all of the time. So we are going to write just that. Y is equal to 3. All right, next example. Again, look at your endpoints and notice that these graphs are connected. So if we establish what the end values are for the domain and range, then that's going to give us the ability to write an inequality. Or in the last one, we did write an equation for y equals 3, but most of these are going to be inequalities. All right, so our x values go from -6 to +6. No, they do not always have to be the same, like a -7 and a +7, a -6 and a +6. This just happens to be that way in this one. X can be anywhere in between. Now, to me, it looks like this is a closed circle, so I'm going to make that less than or equal to. To me, the one on the right looks like an open circle, so I'm going to make that less than. And then for our y values, the lower y value is -3. The higher y value is +3. Again, to me, the circle on the left is closed, so I'm going to make that less than or equal to. The one on the right looks open to me, so I'm going to make that less than. All right, next example. Domain, I believe, let's see, 1, 2, 3, 4, 5. I believe, again, is -7 to +7. Both of those are open circles. Put our x in the middle. It can be anywhere between a -7 and a +7. And then our smallest y value, it looks like, is 1, 2, 3, 4, 5. Yeah, so -5. Sorry. And then our largest y value goes up to here, so that's going to be a +4. So again, if we look at these circles right here, they're open. So I'm going to make that a less than symbol. But that graph comes up and touches the value of +4. So I'm going to make that less than or equal to 4 since it actually touches the value of 4. All right, and then we're going to do number 5 as our last one on this particular page. So again, take a look at our endpoints here. For our x values, it looks like it goes from 1, 2, 3, 4, -4 up to +4. X can be anywhere in the middle. The circle on the left is open, so I'm going to make that less than. The circle on the right is closed, so I'm going to make that less than or equal to. Smallest y value, 1, 2, 3, 4, 5, 6, 7, -7 it looks like. Largest y value is going to be +7. Again, open circle on the left, so I'm going to make that a less than symbol. Closed circle on the right, so I'm going to make that less than or equal to. All right, now again, this can be a little bit tricky to navigate and catch on to, but I'm leaving plenty of examples on that particular page so that your teacher can go back and do some in class with you if you would like, or just use it as a checkpoint to see if you understood what you were supposed to from the video. All right, now for the next set of examples on this video, we're doing the same thing. We're given graphs and we're going to come up with the associated domain and range with each of them. The thing that you'll notice though about these graphs is that they have arrows on the ends. All right, they do not have the open and the closed circles. So we are going to assume, and actually I guess on all of these, even the prior ones, we should have been assuming that all real numbers is what our answer is going to be unless we have restrictions. When you have open and closed circles on the ends of graphs, you have lots of restrictions. Now when you have arrows on the end, you don't have as many restrictions. So in this first example that's already been done for us, as far as our x values go, because of those arrows on the end, they're going to keep, the graph is going to keep going up and out, up and out. So our x values, our domain is going to be all real numbers. Our y values, though, they do have a low point right here of 0, and then just like the x values, they keep going up and out forever after that. So I typically, on this, would just write y is greater than or equal to 0. You see some set notation there, and again, your teacher may talk a little bit more about that in class, but you can simply just write y is going to be greater than or equal to 0. All right, so for our first example over here on the right that we're going to do together, if you look at your x values, again, notice the arrows on the ends. Your x value can be anything under the sun, okay? This is going to keep going down and out, so to speak. This is going to keep going ever so slightly up and out. So all real numbers is going to be our domain. And the same thing happens with the y values. They keep going down as you go out on the graph, so to speak. And so that's going to be all real numbers as well. Now, number 2, by contrast, has a little bit more of a restriction. From a domain perspective, as this is going down, it's going to keep going ever so slightly out. So from a domain perspective, it still is all real numbers. From a range perspective, though, while it keeps going down, we do have a highest value right here. So the highest value that our range can be is equal to 1, and then anything less than that is valid. So range is y is less than or equal to 1. All right, and then jumping down to number 5, I guess it's kind of similar to the one I just did. From an x perspective, this is going to keep going down and out, so to speak. Our range, our domain is going to be all real numbers. Our range, though, does have a limitation at the top, though. The highest value that range is ever going to be a y value of 0, but anything below that is valid. So y is less than or equal to 0. All right, and then the last two I want to do with you are numbers 8 and 9. So on this one, the domain, if you look, we've got arrows on the ends here, but that graph is never from either side going to be a value of 0. We'll talk a lot about this second semester, but this is a rational function graph, and we have what are called horizontal and vertical asymptotes associated with them. We will talk a lot more second semester about those, but trust me when I say for right now, these branches are going to get really, 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 really close to an x value of 0 right here, but they are never going to touch that value. So for our domain, x can be any value except 0. So I'm just going to write it simply like that. And then from a y perspective, these branches are going to keep getting closer and closer and closer to that x-axis, but they're never going to touch or cross over that. So our range is going to be y is greater than 0. It's not going to equal 0, but it's going to be anything above 0. And then number 9, by contrast, the domain's going to be the same thing. Our x values, we've got arrows on the ends here, So our domain is going to be x cannot be equal to 0, but it could be anything else. to the right of 0, to the left of 0. For our range, it's going to be, some of it is similar to the last example, some of it's different. Notice here, we've got a branch that's going to keep getting closer and closer and closer to 0. Here we've got a branch that's going to be getting, from a y perspective, closer and closer and closer to 0, but it's never going to become 0. But notice we have both positive y values and we have negative y values. On the one on number 8, we only have positive y values. On number 9, we have positive y values and negative y values. So our range is going to be y can be anything except 0. All right, again, I've only done part of these so that you have some that you can do with your teacher tomorrow, just as a quick check-in if she chooses to do some of those with you. But for now, we'll end this particular video.